Good morning, or should I say greetings, since we may have people logging in from diverse geographic locations, given our virtual meeting. Anyway, before I start the presentation, I'd like to put things in perspective and give you some context to this whole presentation. Engineero as a company, for the last 2 decades, we have been supporting process manufacturers globally with providing engineering, analytics, operations support. And over the last 5 years, a lot of our clients have come to us and we've gotten involved with some of their digitalization initiatives. And we've been implementing solutions for several of these clients. So what I will be sharing today with you is what we've learned through some of these implementations and experiences, and how we can really extract value from some of these digitalization implementations. I'm reminded of a meeting we had with the CEO of a large corporation who had just finished elaborate digitization of a lot of their plant sites, and they also had all their data accessible at the corporate office. They could pull up any site and have a very good looking dashboard giving various kinds of data on what is really happening at those facilities. But the CEO was telling us, hey guys, we've done all this, but we're still not seeing any value, and how could you help us there? This is not the first time we heard it, and was also not the last. And we've heard several people at different levels within organizations with our clients sharing something very similar. So this kind of has guided the approach we've taken with digitalization in a lot of our implementations. Let's look at what the whole digitalization initiative is at a high level. It's use of smart digital technologies, associated business processes changes along with some of these implementations. You typically would get a more intuitive experience, augmented intelligence to help you do things much, much better. Better monetization of resources, and above all, new revenue potential, value providing opportunities. So this is typically the execution flow. Now, what we've seen, if we focus our digitalization initiatives with measurable business outcomes, so when we do the planning, work backwards. This kind of a thought process when planning digitalization initiatives, we found to be extremely valuable and almost guarantees success through any of these implementations. So this is really a starting point. Now let's look at digitalization and what I call intelligent digitalization, which is really required to be able to extract value from any such implementation or application. So if you look at a digitalization map, you have the production facility, data is collected, data is then made available either locally or through Internet of Things to any location. Collaboration that enables various teams to collaborate wherever they may be. Manufacturing support teams get a lot of information from this data. So that's the traditional, what people used to call digitalization. And this is really where the company was, when we were talking to them 5 years back, the story I was telling you right at the beginning. However, this is what we found. Direct use of data for business intelligence without decision insight analytics can be hugely misleading. And this is mainly on account of the errors which are typically inherent in a lot of this data in this process manufacturing area. And this making this data usable requires advanced analytics solutions. This is something that fits right into our our backyard, if you will, because we've been doing analytics for process manufacturing and supply chain for the last 2 decades. And this is really the basis for some of the intelligent software solutions we provide for process decision excellence. We call it AICHE. This is what allows intelligent digitalization and not just the vanilla dashboards purely taking the data. And this is really what enables the transformation and the value capture that one looks forward to from such a digitalization program. Typical problems that are addressed by such solutions, well, they vary from costs, safety, environment, efficiencies, better revenue opportunities, unforeseen costs and downtime are addressed, plant downtime, lost production is addressed, lower margins, competitive risk, timely handling of crises, retro analysis. So these are various areas that really get addressed. So with a solution like this, at the end of the day, the solution core could vary in complexity, and you could have descriptive analytics, diagnostic analytics, or prescriptive analytics. The value varies on the type of core analytics that is being done. Essentially, what all this does is it provides augmented intelligence, and the consequences are fewer instances of lost opportunities to improve efficiencies, lower number of safety events, lower number of unplanned shutdowns, better maintenance planning, and so on. So see, these are some of the areas that are really consequences of solutions like this. Now let's take a quick look at what such a solution really looks like, just giving you a very, very high-level overview. All starts with data. The data is really taken, and they are converting that into information. So the various required pieces in order to generate the insights and intelligence that is required are several advanced analytics tools like machine learning, advanced artificial intelligence, then fundamental models for whether it's specialized equipment or regular simulation models, deep data processing and mining, smart data platforms, taking care of data security, modern technology stacks, business intelligence software to really provide intuitive output. And above all, this is what often gets missed, which is a key requirement, is the specialized engineering work processes that are required to package all this. And that's something we call DEEP, or Decision Excellence Engineering Process. Now, all this can be implemented on premises or on the cloud, or it could be a hybrid depending on what policies and requirements are on the client side. Let me tell you a little more about this whole decision excellence engineering process, DEEP. That's really what enables the whole transformation at the end of the day. Take a typical plant. You have key performance indicators. Manufacturing teams are, their KRAs are to improve KPIs from where they are to much better values. You have several different tools today as part of the Industry 4.0. You have machine learning, artificial intelligence, IoT, first principles, big data, BI, and these are all technology tools. But to using the data, you need this whole decision excellence engineering process, which requires domain knowledge, software engineering, data science. So it's really a multi-dimensional team really looking at it to end up with intelligent software as a solution to directly address your the issues you're facing, or to provide you the augmented intelligence to enable the manufacturing teams to move from point A to point B. So that is the key enabler, this whole deep process. It aligns operators and engineers to achieve and track realistic operations targets. And let me tell you now something about tools versus solution. As I keep mentioning, you don't implement technologies just for the sake of implementing technologies. It's really a solution that's at the end of the day going to address a problem that you have. And that's the difference. Tools are like atoms. When they're all put together, they form a molecule, which is the solution, which directly addresses your problems and provides you, the augmented intelligence. Like I said, the decision excellence engineering process, DEEP, is a key fundamental requirement to make all this happen. Now, this whole DEEP process, success is an analysis by an analytics team. I view it as a necessary prerequisite. And this is what we've learned through our experience, that this is something that is very, very essential or necessary experience to be able to pull a solution like this together that is stable, robust, and can function automatically with minimal false positives. That the stable operation with minimal false positives is very important for a solution like this if it has to be utilized and not, fall by the wayside. So having gone through this process, taking the data source, doing the synthesis, doing the core analytics, interpretation, going through the workflows, business intelligence, and ultimately providing the augmented intelligence, that whole process, having gone through it numerous times, I think is a fairly necessary prerequisite if one has to very effectively provide a solution that's going to be robust enough. And so that's a piece again that is often missed in when something like this is pulled together. Here are a couple of case examples of how deep process has helped some of the ethylene plants. I'll take just a couple of examples. Here's an example. The initial engagement purpose was to achieve operational excellence, address some of the challenges being faced, like lower furnace run length, lower yields, reliability. The results were phenomenal, really. Improvement in furnace run lengths from 50 to 90 days in this case, improved yields, significant amounts, increased ethylene production, annual savings, and several techniques and expertise were employed, like data analytics, fundamental modeling. And you'll see a lot of this was really done way back, as early as 2005, and then that continued and it was fine-tuned in several of the later applications as well. This whole deep application process was again done. This is a much more recent application for operational performance improvement, where beyond deep, some of this was also deployed as digital twin models and operating automatically on site. Again, very impressive results here from an application of this nature. Now let's take a sampling of what some of these solutions may look like. Example, dynamic benchmarking. This is a solution where automatically the operator can get information on, hey, this is where you're operating. You have actually operated historically much better given the same kind of situation and conditions. And he automatically has that and sees why the difference and how he could achieve that, instead of having to go and search through that through the historian himself, which could take days. And this is there at your fingertips. Instrument drift, combination of soft sensors, machine learning applications, identifies drifts in instrumentation, faulty instruments, plant performance evaluation, plant performance tracker, monitors how the control systems are functioning and what could be done to improve the performance. Equipment health monitoring, predicting furnace run lengths, compressor performances, heat exchanger tracking, early warning deviation trackers gives you an early warning signs instead of learning about problems or anomalies at the 11th hour. So all this is part of the intelligent software solutions, and clients of ours have implemented all of these or some of these along with some other solutions. I'll quickly take you through a sampling of some of the displays from implementation of such solutions. We'll quickly run through it just to give you a glimpse. Here's a unit overview, gives you a quick overview of the key performance indicators, and this is constantly updated through validated data. Gap analysis quickly shows you a drill down. Hey, this is the gap between where you are, where you could be operating in a much better place, and what causes the differences, where is the difference coming from. Very quick drill down. Reporting, whether it's time reports, predefined reports, custom reports, that can be automatically generated. Overview of the analytics gives you a complete overview of the entire facility. In this case, it's an ethylene facility. And it shows you where to focus, color-coded. And you can further drill down to the equipment level and look at, what the live benchmarking is telling you, giving you where the gaps are coming from, what you could change, to close those gaps, equipment health, again, drill down to the equipment level, providing furnace run length prediction, compressor performance predictions, drill down to equipment level for instrument drift, showing you exactly which instruments are faulty, and also predicting if the instruments fallen off, using soft sensors to predict what actually the measurement reading could be. Deviation trackers, giving you early warnings of abnormal deviations. Interestingly, say, for example, furnaces, they are degrading systems. And, the traditional statistical 3 sigma models will not work. You need much more elaborate machine learning models to really be able to track these kind of equipment. Controller tracking, again, monitoring the performance of BMC controllers. So that's just a glimpse of, some of the output and dashboards from a solution like this. So I just wanted to give everything to you in a nutshell. You can get further details. You can visit us on our website, and post a query there or contact us through the details given there. So this is a quick overview of our company. As you can see, we are present globally, and traditionally some of the areas we are very actively involved with. Thank you for your attention, and have a good rest of the meeting.